For this project, the task was to figure out the height of a tall object that we could not physically measure. For our object, we chose a scoreboard on the school field. To measure the height of the scoreboard, we used a trick that is based around the principles of an isosceles triangle. The materials that we needed to do this were a protractor, a straw, a level, some tape, 2 measuring tapes, a camera, and a tripod. Figuring out the height. Step 1. Collecting data. First, we tape the straw to the protractor directly on the 45-degree line. Then we tape the level parallel to the 180-degree line on the protractor. After that, we set up the camera and the tripod on the field perpendicular to the scoreboard so we could take pictures for reference. Then we laid out 1 measuring tape directly to the right of the scoreboard so we could measure how far away we were standing from it. After that, Nela stood next to the measuring tape and held the protractor up to her eye so that she could see through the straw. Then slowly started walking backwards along the measuring tape until she could see the top of the scoreboard through the straw. All of this was done while keeping the protractor level. This is what the level was used for. Once Nela could see the top of the scoreboard, Hannah took the measurement of how far away she was standing from the scoreboard with the measuring tape on the ground, and Cohen took a few pictures using the camera on the tripod to use as a reference for later. Hannah also used the second measuring tape to measure how far the bottom of the straw, taped to the protractor, was above the ground. We recorded these 2 measurements on our phones. After that, we took everything back inside and put it all away. To solve for height, we didn't even need to do that many calculations. Because we used a 45-degree angle on the protractor, that made the angle of depression from the top of the scoreboard also 45 degrees. This makes the triangle we formed an isosceles triangle. In an isosceles triangle, the opposite and adjacent legs are the same length, so the measurement we took with the first measuring tape is the same as the height of the triangle we formed. So, to solve for the height of the scoreboard, all we needed to do was add Nela's height to the height of the formed triangle, giving us the answer of 261 inches tall. To verify that we measured the angles correctly and actually formed an isosceles triangle, we plotted a right isosceles triangle against the picture we took from the tripod to see if all the vertexes lined up where they were supposed to. As you've seen throughout the video, and right now, the triangle is isosceles, making our answer of 261 inches tall for the scoreboard correct. Reflections. Question 1. Does your distance to the object affect the height of the object? Explain why. Your distance to the object does not affect the height of the object. As you can see in this diagram, we are manipulating the distance of Nela from the scoreboard, but the height is remaining the same. This is because the height and length, or opposite and adjacent sides, of the triangle are not directly related, so one can change without the other being affected. Question 2. Is it necessary to include your height in your problem solving? Explain why. It is necessary to include one of your group members' heights in the problem solving to an extent. Because the triangle we formed was from Nela's eye level to the top of the scoreboard, we needed to include that distance in the final height of the scoreboard. Therefore, we technically needed to include Nela's height in the problem solving, only the distance from the ground to her eyes though, not her full height. Question 3. Do you have to apply trigonometry in your problem solving? We had to use trigonometry in our problem solving, although not trigonometry ratios. Because the principles of an isosceles triangle falls under the category of trigonometry, we did end up using trig. To recap, both the opposite and adjacent legs of an isosceles triangle are the same length, making both of the non-right angles in the triangle 45 degrees. Thank you for watching, and we hope you learned something.